We've seen that modern cosmology tells us that the universe has a finite age, that it appeared about 13.8 billion years ago. Wait a second, you'd say. If the universe had a beginning, what was going on before? Well, this is a fair question, but the wrong one to ask. The concept of time implies that there is change, that matter transforms in some way. If nothing changes, what's time for? The idea of the Big Bang tells us that there was no change before the beginning of time. It's a sort of dead end where Einstein's theory fails miserably. Actually, as we'll see in the next 2 weeks, the theory fails because of quantum physics, the physics that describes atoms and elementary particles. Einstein's theory is a classical theory that breaks down at very short distances. With time approaching zero near the beginning, the universe shrinks to nothing, at least according to Einstein's theory. Nothing is not a very physical concept. The point is that when you get close to the Big Bang, the whole universe is tiny, and we need to include quantum effects to describe what's going on. The problem is, we don't know how to do this yet. There are ideas with names like superstring theory or loop quantum gravity, but we aren't sure they will work. And even if they do work very close to the beginning of time, they won't crack the mystery of the Big Bang itself, of the origin of everything. Why not? Because science needs physical concepts to work, things like space, time, matter, energy. We use laws of nature to order these concepts and describe what's going on. The origin of everything implies also the origin of the laws of nature. Where do they come from? We would need some sort of meta-theory, a theory that not only describes the universe we live in, but also all possible universes with different laws of nature. Although we don't have this theory and have no clue how to think of it, we have something that is closely related to it, the idea of the multiverse. The multiverse is essentially a collection of coexisting possible universes, ours included. It is predicted to exist in certain theories, although we don't know whether such theories are right yet. There are different kinds of multiverse depending on the theory that speculates about it. And in some of them, the values of the physical constants we use to describe nature, like the values of the electron mass and its charge, or how strong gravity is, can be different in different universes. In this case, our universe would be a pretty interesting one, where these constants are such that stars can form and shine for billions of years, allowing for life to emerge. Most universes presumably would not be like ours. The multiverse is an attractive idea, although it creates a lot of problems. The most critical of them is that we can't be sure whether the multiverse exists or not. Since these other universes are outside our cosmic horizon, we can't receive information from them. And if we can't receive information from them, we can't test their existence directly. Some physicists suggest that neighboring universes could have brushed against ours in the past, leaving an imprint in the radiation across the sky. The idea is really interesting, but so far has not produced any convincing observations. From a philosophical perspective, the multiverse is a conundrum. If we can't test its existence through observations, how can we use it as a physical concept? How can we know whether it belongs to physical reality? The question remains open, although physicists are not waiting for its resolution. Research on the multiverse keeps on going.